Now, as I was mentioning with the different methods, each element of a vector object is a reference variable of type object. So what is object? Object is a predefined class where a reference variable of this type can store the address of any object. So this is kind of like the higher up object class, and all the other classes are kind of subclasses of that. So I can do vectors of strings. I can technically do vectors of scanners, ints, floats. Any class that I can create, any object I can create would be a subclass of the object class. So the whole point here is if I want to add an element to a particular vector object, I first have to specify what is going to be that object type, and then I can store the data to that object. So I can do a vector of integers, but I have to make sure I specify that we have a vector of integers. So then we can just store the memory address of that object into the vector itself. Here's an example of declaring a vector of strings. So I have vector, and then notice I have this string in less than greater than symbols, and then the name of my vector list, and then new equals new vector, and then once again I got to specify the actual type, or the object type. So here we're doing a vector of string objects. So yes, this creates a vector of strings. So the point here is that whenever we declare a vector object, we have to specify the reference type that the object is going to hold. And we do that by enclosing the object type with a less than symbol and then a greater than symbol, and then that's placed after the word vector. And if we don't include this, the compiler will give us a warning. It's going to say, I see you're trying to create a vector of some type of object, but you're not specifying what that object is. So it could be anything. It would be nice if you just specify what exactly you're supposed to be putting in here. So once we've created the vector, now we can add however many elements we want to it. So for example, let's say I want my list vector to be a vector of seasons. So I can do something like list.addElement and then include spring, and then list.addElement summer, list.addElement fall, list.addElement winter. So this will add these 4 strings into my vector. Now let's say I were to run system.out.println into my list. What would be my output? Well, it would be spring, summer, fall, winter in square braces. So this would be the formatted output for my vector. Now, it's just worth noting that if we're going to use vectors, we need to import the java.util package to make that work. Now, for vectors, we have this pretty much what seems like an array of objects. We have a vector of objects. So if every element is an object, then what about primitive data types? What about integers, doubles, floats, and so forth? Well, we're going to need to wrap the data type in an object. So how do we do that? Well, if you remember a while back, we talked about a wrapper class. And we talked about a little bit about this when we were passing integers and doubles as objects through methods. So we can use this wrapper class that corresponds to each primitive data type. So for example, let's say we wanted to use the wrapper class for integers. Well, I can do integer num. So integer in this case right here, it would be a class of where we have an integer object. And then either these last 2 lines, so num equals 25 or num equals new integer 25, would have num point to an integer object which would store the value 25. So the whole point here is if we want a vector of a primitive data type, we need to create an object of that type. So we can use like integer and so forth to create those objects for us. So here's some code where I create a vector of integers. So notice that I have vector and then integer in the less than and greater than symbols. Then I have num list equals new vector integer. And then I can just add whatever elements I want. I can use 13, I can pass 15. So these will create objects of those values and store those in our vector. We can use our num variable that we just did from the last slide, and we can add that object into our vector. The whole point here is just we take advantage of these primitive wrapper classes to handle things like int and double and so forth. And we can use this wrapper class for other types too. So if I want to use a character variable, I would need to use the character, the left-hand part, so this part right here, character. So that would be my class that I would use. For double, I would use double with the D capitalized. Float would be float with the F capitalized, so kind of see the trend that's going on here. And then for Boolean types, I would just have Boolean with the B capitalized. But we have all these wrapper classes for our primitive data types. And if we want to process each element of a vector, well, since we don't really have an index per se, we can use the for each loop to take care of that. So we can process each element of a vector using the for each loop. So just to give an example, we want to print uppercase strings, we can do something like for and then string str and then have our list be our array. So just like we were using the for each loop for arrays, we can use the same setup for our vectors. So we have the name of our vector right here, and then the element in there would be stored in str, and then I can just print something like str.toUppercase.